Hi, my name is Veronika Solopova, and today I would like to present you our paper, which is called Improving Sentiment Analysis for Ukrainian Social Media Code Switching Data. Um, and I wrote it together with Yurii Shynkarov from um, Ukrainian Catholic University and with Vera Schmitt, who is my colleague in Technical University Berlin in Quality and Usability Lab Explain LNP group. So, sentiment analysis is quite a popular topic. Usually, it's defined as the process of computationally categorizing opinions expressed in a piece of information. And basically, this is a very popular task, quite covered in other languages. However, when we looked at the existing models for Ukrainian language and Hugging Face, we understood that they don't really work. And actually, good sentiment models are very powerful tools for businesses and governments and NGOs and any kind of organizations to monitor products, to monitor public opinion at scale. And basically, there are also a number of publications looking into how sentiment analysis actually predicts election outcomes better than polls. So basically, it's a quite powerful tool. Then it really works fine. But difficulty is that annotated data is quite scarce as of now, and then there is the effects of code switching complexity of Ukrainian data, meaning that basically in the same social media, Telegram channel, for example, you would have both a lot of standard Ukrainian, a lot of standard Russian, and a lot of so-called Surzhyk, the basically the mixed variant. And it also can be both intersentential and extrasentential. So basically, in the same sentence, you can have different languages, or you can have the mix in one. We decided in our work then to basically focus on Telegram data because it is one of the most popular ones, and obviously it's also the most legal one nowadays to easily scrape. We also figured that we still would want to produce real human annotations because, there are a number of studies, including ones with Ukrainian and, for example, Russian data from Ustanovich here, where they showed that basically, human annotations and GPT annotations would actually, LLM annotations would actually not be that similar on sentiment analysis topics. So that's why it might make sense basically to still annotate your data. And then we looked at the available annotated data. Many basically actually rather look at sentiment as stance. So basically any kind of news which supports Ukraine, for example, or support Russia, which is basically not necessarily what we would want. So this is too focused. We also saw that a lot of data is actually not even annotated then, even if it claims that it's annotated. Some data sets are nice, but very small, even if they are manually annotated. And then some data sets are actually half human, half LLM annotated, and these are mostly done in Russian, even if it's Ukrainian data. So that's why we present our dataset, which is called Cosmos, which stands for a code switch multilingual sentiment for Ukrainian social media. Basically, the collected data spans from February 2022 to September 2024. The total size of the collected texts we annotated is 12,224. And basically, out of those a bit more than 7,000 stands for basically Telegram messages from big channels. We also integrated two publicly available datasets, TG samples from Baida et al. With 300 samples and 100 samples from Yekaboo book reviews and 100 product reviews from Hotline, so that we also basically add this more of this idea of commercial and product kind of reviews and opinions. Then we decided to annotate it with four classes to make it a bit more comprehensive. So we didn't go for super classes like super positive and super negative, but we still decided to include a lot of mix. In terms of lengths, basically you can see here that messages are also quite interesting because they are usually longer than the others, um, but which makes sense because they have to incorporate, to incorporate both negative and positive sentiment. Usually it should be very often a complex sentence, so where in first sentence they would say something positive about something and then contrast it in the second sentence, so that's why they are longer. Then based on the languages, Ukrainian is the most predominant one. Then there is also 28% of Russian, and then the code switch content actually stands for 6% of the data. And basically the code switching annotations were made with GPT-4 model, which we instructed, and then we also validated it on 100 samples and saw around 80% accuracy. So basically, this is more or less reliable data. Basically, about the annotations, we found four more annotators in addition to the two first offers who agreed to join this project. Basically, the average pairwise coin kappa agreement was 79%, indicating substantial reliability. Basically here we can see that neutral class, as often it is the most representative, but actually it is almost balanced with the negative class messages. Then positive one is much lower, basically almost twice lower, and then mixed class is the smallest one, but still quite present. We can see that basically this inter-entity agreement was also quite well distributed among all of the participants. So basically, so what we decided to do is we basically tested two types of approaches, which are quite classical now. So we used prompting baseline with GPT-4o and DeepSeek V2 chat, where we would work with different prompting strategies. And then we used bird family models like Roberta and Modern Bird, which are, so Roberta is basically trained on Ukrainian data specifically. I think it was presented in one of the previous UNLP basically years. And then Modern Bird is also an update of Bird from, I think, this year. Basically, we first tested our LLM baseline across all configurations. Prompts in English consistently outperformed Ukrainian prompts for both LLMs. So that was quite interesting. And the performance gap between Ukrainian and English prompting was very much pronounced in zero-shot prompting. So basically more than in few-shot setting. That was also an interesting finding. GPT-4o consistently outperformed DeepSeek on our data set, meaning, basically that GPT-4o has stronger multilingual capabilities, which were already shown in previous research. Then we also played with augmentation techniques. So basically, although our data set is already quite big, we still wanted to play with basically increasing the size. And then we basically used word substitution as augmentation technique. And we also used back translation. And we can see that word substitution was actually quite useful for the small language models and for LLMs, which is obvious. I mean, we were not fine-tuning them, but only basically influenced the test set. Basically, it didn't have much influence. Finally, when we look at the overall results, we can see that basically Roberta was the more efficient of the two small language models, very clearly. So the only setting where it performed a bit worse was Russian language, but it actually performed quite well in code switch one and the overall. We also not only looked at classical precision recall and F1, we actually also looked at expected calibration error because basically it evaluates how model predicted probabilities reflect true likelihood of outcome, which basically shows model calibration, which is very useful because we can see how the model really performs on different subsets of data, or in our case, different language settings. And we can see that Roberta was basically much better calibrated, and with EC score, we basically want the smallest values possible, preferably around 0.1 or below. And actually here we can see that Modern Burnt is actually quite badly calibrated. except for Russian only setting, but even there we actually see very similar results. So overall, Uka Roberta is much better, basically, set for Ukrainian social media. In terms of calibration, we also looked at these reliability diagrams, where basically we can see the reliability line, which would show the perfect calibration. And we can see that basically the overall calibration, so basically we want these bars to touch as or go as closer to this line. And if it's over this line, the model is overconfident in this beans of probability. And if it's below this line, it means that the model is underconfident. We can say that overall, in majority, the models are rather underconfident. We can still see some places where modern BERT is overconfident, especially on Russian-only text with high probability bins, and also on basically code switch text with low probability bins. But overall, we can see that basically Uka Roberta is much better, or like much closer to this calibration line on Ukrainian overall setting, but both models, as we can see, are much worse calibrated on the code switch text, which were still like smaller size of the training set, obviously. We also applied a little bit of explainable AI methods. So we used Lime scores and attributed basically them to each sentence in the test set to see, yeah, to basically get some insights on what is important for our models and what is like if there is a potential language related bias. We can see that, and because we had two settings, basically the free class model without a mixed and four class model with mixed class, basically we can see that in the free class setting and overall, basically for Russian language, the words would have much more. So the terms, basically high Lime score terms, would usually contribute to negative prediction of the model, and basically almost never to the mixed, for example, in Russian case, while Ukrainian one would actually often contribute to the basically mixed prediction or positive one. So basically, it means that Ukrainian. So this one was only done with Ukur Roberta, and we can see that it clearly is a little bit kind of discriminating against Russian language, which is historically still we argue in the paper it's still acceptable because we would certainly not want a Ukrainian model to be discriminating against Ukrainian language, but in the current, especially political setting, that a small kind of bias would rather be acceptable. Some other interesting insights we got is that so for positive class, some terms which contribute to like statistically to positive prediction or prediction of positive class make generally sense, but they sometimes are actually ambiguously positive depending on the situation, and which means that basically this kind of situation was correctly predicted as positive, but some irony, sarcasm, and colloquial usage make interpretation kind of harder. And a lot of misclassification were really caused by such cases. In terms of negative class prediction, a lot of high Lime score words were related, or some profanity words also very often were related. And basically, they were so negative class was the most emotional one, also like with emotional intensity. While laughter tokens sometimes misleadingly signal irony or sarcasm and thus cause misalignment, basically mispredictions. Then neutral class was basically constituted a lot of emotionally neutral terms, so some conjunctions, generic verbs. And the interesting thing that it was clearly, it kind of was clear that sentences were predicted as neutral due to the absence of strong sentiment cues and not due to the presence of these neutral ones very often. And then finally, the mixed class was basically using few clear markers. So it was really difficult to draw clear conclusion or like clearly understand what was the pattern here, but basically, indeed, it included some negative, some positive words, and it means that the model doesn't have a very strong concept for mixed sentiment. So to conclude, we developed Cosmos, a publicly available dataset of 12,224 texts covering Ukrainian, Russian, and code-switched content with human annotations of high quality. Our experience demonstrated that targeted words substitution can substantially improve fine-tuning results, while back translation often degraded model performance. And finally, fine-tuned Ukur Roberta combined with word substitution augmentation achieved the best results.